All right, in this next example, they're going to be looking for the standard deviation, the IQR, and the range. But before we do that, I want to go over these, which are called the 5-number summary. They're one of the more known things that you do in statistics. You're going to do them a lot. It's called the 5-number summary, and what it is, it's the minimum value, the first quartile, the median, the third quartile, and the maximum number. And let me go over each one and how to calculate. The minimum is just the lowest number in the list. You want to put all your numbers in order, like they did right here, and I did over here. So the minimum would be 16, and the max would be 37. And so those were easy, right? The maximum, just the biggest number. The minimum is just the smallest number, 16. The next one you always want to calculate is the median. I know Q1 is next, but we're going to do the median because it's the next easiest one to do. And the way you find the median is you want to figure out where you chop these numbers in the middle, the exact middle of these numbers. And since there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them, the chop would be right there. And since there is an even number of numbers, the chop didn't hit a number exactly. Think if I had like 1, 2, 3, and I chopped them, I would chop it 2. In the middle would be 2, right? The median equals 2. But that's not what this one did. This one has an even number, so the chop became between 28 and 29. So to figure out the median, it would be equal to these two numbers averaged together, 28 plus 29. Oh, that was ugly. 28 plus 29 over 2, which is 28.5. What's the number between 28 and 29? 28.5. So the median is 28.5. It's like the middle number of the group. So the minimum was 16. That's the beginning point, right? And the maximum was 37. That's the end point. And we found the middle, which is like the halfway point. Q1 and Q3 are called quartiles. And the way you find quartiles, and think of quartiles like quarter, 25%, right? You're cutting it into fourths. So how do I cut into fourths? I take each of these, like each half, and cut them in half again. Since there's 5 numbers, the cut in half would be right there in the middle, which is 24. So the quarter 1 equals 24. So we began at 16, and then our quarter point, where 25% of the numbers are, would be 24. And then our halfway point, which is called the median, think of that as Q2, but they call it median because it's quarter 2 is like the midway point, right? And then quarter 3 would be the chop middle point in this half of the graph, in this half of the numbers, and it's 34. So Q3 equals 34. So Q1 is 24, and Q3 is 34. So this is called the infamous 5-number summary. And think of it as the beginning, 16, the fourth of the way through, 24, halfway through, the median, 28.5, 3/4 of the way through, quarter 3, 34, and then the maximum, 37. So that is your standard 5 numbers. And from these, you can find what is called the interquartile range. And that sounds all fancy, but all it is quarter 3 minus quarter 1. And you see what I'm doing, since I chopped it up into 4 pieces, basically. You know, this one out here, between Q3 and the max, this one right here, between the median and Q3, this one right here, and this one right here. It's the middle two, Q3 minus Q1, from 24 to 34, right? So the IQR is equal to Q3 minus Q1, which is equal to 34 minus 24 equals 10. So the IQR is 10. And what the IQR is and why it's important is it is the middle half of your data. So it's like 50% of your data is in this middle half right here between 24 and 34. So interquartile range just means inner 50% of your data. How far do the numbers go? They go from 24 to 34, so they go 10. And the last one we'll calculate in this video is the range. And range is just biggest minus smallest. 37 minus 16 is 21. And think about it. If you wanted to say like how far spread out these numbers are, you would say the range, right? 37 minus 16. And you would get 21. And that's like, okay, the numbers range from 16 to 37. But what if you had these numbers, and then you had a number out here that was like 5,000? And you wanted to describe how spread out the numbers are. This 5,000 is not like the other numbers, right? It's way away from the other ones. The range would tell you it's from 16 to 5,000, which is, 4,984, which is way too big. It doesn't really range that far, right? The vast majority of the numbers are from 16 to 37, so the better measurement of how spread out they are is the interquartile range. And you notice how it's not really going to change that much. And it would stay around 10. So if you have like a big outlier or something, you want to stay away from range, because range becomes not very accurate. Do is calculate the standard deviation. Think about that word deviation. What does it mean? It means how far away from normal you have went, how far away from the mean, the average you have went. And this is the equation for it. We are only going to solve this equation one time, because you will have a calculator to do this for you. But I think seeing it done by hand will give you a good idea of what those numbers actually mean. If you just type it into a calculator and get an answer, it doesn't tell you what it actually means. I want to show you what it means by standard deviation. And what a standard deviation is the average distance from the mean, the middle. So let's calculate the mean. And that's what this little x bar is, or y bar on top. So x bar equals, you add all these numbers up. You can do that in the calculator now if you want. You can pause if you need to, but I'm going to add them all up. And I'm going to get 280 divided by the total number of numbers that we have, which is 10. 280 over 10. So the average is 28. So my mean is 28. And what they're asking you to do is take each number in here. Take every single number and subtract 28 from it to see how, because if I subtract, it tells me how far away from the middle I am. So it's seeing like how spread out these numbers are and how far away from the middle, the mean they are. So let's do that. If I get 16 minus 28, I get negative 12. So it's 12 away from the middle, right? And then I get 21 minus 28, that is negative 7. 24 minus 28, and you get the picture, right? Negative 4. 26 minus 28 is negative 2. I'm not going to keep writing the subtraction. You can subtract. 28 minus 28 is 0. 29 minus 28 is 1. Oh, that should be a 0. 30 minus 28 is 2. 34 minus 28 is 6. 35 minus 28 is 7. 37 minus 28 is 9. And then it wants you to square them, because look at the equation, you square them. And the reason they do that is because we don't care what direction they are away from 28. If they're bigger or smaller, all we care about is how spread out they are, how far away they are from 28. So we want to square them to make them positive. What is negative 12 squared? 144. What is negative 7 squared? 49. Negative 4 squared? 16. Negative 2 squared is 4. 0 squared is 0. 1 squared is 1. 2 squared is 4. 6 squared is 36. 7 squared is 49. 9 squared is 81. So what they're doing is that little symbol right there, that sigma, means sum, which means we're adding all these numbers up and then square rooting it, because we need to square root it because we want to get it back to its normal numbers like this, how far away it is from the middle, and we want it to be positive. So if you square a number and then square root it, you basically turned it positive, right? Except we're going to divide by n minus 1, by how many numbers there are, minus 1, which is the degrees of freedom, which we will not get into anytime soon. We might not get to it all in in on-level. You might get into it in AP stats, like what exactly it means. Okay, so I'm going to take all these numbers and add them all together, right? Like sum them all up. So go ahead and do that in a calculator, and I'm going to do it in a calculator and get back to you. And you can pause the video now. All right, so I added all these numbers up, and I got 384. So adding all these up squared is 384. See, I squared them and added them all up, right? So that top is 384. So the standard deviation is equal to the square root of 384 divided by 10 minus 1. And so that would be the square root of 384 over 9, which I'm going to put in my calculator. And I am going to get 6.53197, and that is my standard deviation, 6.53197. And what that is it's a measurement of, on average, how far away they are from the mean. So I did all this by hand just to show you how they're calculated, just to show you how quickly we can get all of these numbers using Stapplet. You will probably never do these by hand again, but I wanted to show you where they come from. So I'm going to go and I'm going to type in all this data here. One quantitative variable, single group. And this is example 4. And I'm going to copy and paste those numbers. If you can't do that, once again, just pause and type all the 10 numbers in and begin analysis. And watch what I get here. N is 10. N is how many numbers there were. You can count them. 2 rows of 5 right there. There's 10. The mean was 28. Was that what we got? Yes, it was. See, mean is 28. That matched. Let's make sure all of them match. The standard deviation is 6.532, 6.53197. They just rounded it off to 6.532. That is correct. The minimum was 16. The Q1 was 24. Correct. The median was 28.5. See, that was correct. The third quartile is 34, and the maximum is 37. So I did all of that just to make you see how they get these numbers. You will probably never calculate those again on your own. I just wanted you to see where they're coming from, so just conceptually you can see what they are and what they mean. All right, that is the example number 4 in your notes.